Hello and welcome to the third in a series of webinars related to NERC CIP compliance. My name is Kevin Johnson, and I'm the Vice President of Corporate Business Development for NovaTech. And I'm joined today by two other individuals, Ray Wright, who's our Vice President of Marketing for NovaTech, and Richard Powell, who is the Manager of NERC CIP Compliance and Business Development for PAS. During the webinar, we'll encourage you to either type in your questions in the question box or email them as appropriate, and we'll respond to the folks either during the session or at the end of the session. Also, we want to remind everybody that this session will be recorded as a video, and that PowerPoint presentations will also be made available. Now let's begin. The topic of this webinar is NERC CIP Section 10, Solution from NovaTech. Just want to outline the agenda for our session today. We're going to start out with a company overview, both of NovaTech and PAS, an overview of what is included in NERC CIP Section 10, and the Orion LX in Substation Asset Module for NERC CIP compliance, and also an overview of the PAS Integrity Enterprise Solution. NovaTech is one company with three divisions. We have a division that is located in Lenexus, Kansas, that's responsible for our Orion substation automation platform. We have another manufacturing division that is located in Bethlehem, Pennsylvania, and that is responsible for our Bytronics metering and instrumentation division. And we have a third division that is in Owings Mills, Maryland, and that's responsible for our D3 DCS system. NovaTech is headquartered in Quakertown, Pennsylvania. We have approximately 235 employees, and we have multiple sales, engineering, support, and training locations throughout the U.S., and also an expanding international presence. NovaTech also has an extensive customer base of investor-owned utilities, original equipment manufacturers, municipal power and cooperatives, Fortune 500 industrial customers, and over 100 new users in the last 3 years. PAS was founded in 1993, is known as a provider of human reliability software for safe production, serving power, oil, gas, and processing industries globally, with global locations in the Americas, Europe, the Middle East, Asia, and Australia. Their technology includes the Integrity Automation Asset Management Software and the Plant State Suite Operations Decision Support System. From a business strategy, they are concerned about innovative technologies that are inspired by domain expertise, strategic customer relationships, mission-critical software solutions, and they invest approximately 20% of their annual revenues in R&D. They also have positioned themselves through thought leadership and strategic partnerships around alarm management and high-performance HMI. They are also the author of handbooks related to alarm management and high-performance HMI, and members of various different committees. You may ask the question, why NovaTech and PAS? Well, NovaTech and PAS have been strategic partners since 2011. With a common customer base and NovaTech's nearly 30 years of process automation experience, PAS is also recognized as an industry leader in configuration and change management software. The NovaTech PAS solution can be implemented across the enterprise to include control centers, generation facilities, and substations. As you can see, PAS has a large number of top-tier energy, power, chemical, and mining customers. They have their software installed at nearly 1,000 or more plant sites, over 8,000 software licenses, manage over 20,000 automation assets, and have 28,000 users worldwide. NovaTech is dedicated to superior customer service and innovative projects and unmatched ease of configuration of our software tools. We have more than 10,000 installed devices at hundreds of utilities, and we are a market leader in substation automation processors. Today we're going to tell you a little bit more about our solution, a combined solution between NovaTech and PAS, and the benefits and advantages that it brings to NERC CIP compliance. NERC CIP version 5 is comprised of several different areas, from CIP 2 through CIP 11. And as you'll see from this chart here, the items in red are the solutions that can be provided by the combined NovaTech PAS offering. Previous NovaTech webinars included version 5, NERC CIP 10 and 11 webinar that was conducted on 8/22/13, and also meeting NERC CIP 7 with the Orion LX. Both these webinars are posted on our website, and the videos can be reviewed. Now for a summary of CIP 10. CIP 10 requires that you define a baseline configuration for all critical substation assets. This includes operating systems, firmware, any installed software, any logical network accessible ports, and any security patches applied. Critical systems and assets include electronic access control and monitoring systems, physical access control systems, and protected cyber assets. If any changes, the system updates baseline configuration and documents those changes. It will determine the impact of changes and document, and test effects of changes and documentation. You're also required to monitor for changes at least once every 35 days and perform paper vulnerability assessments every 15 months, as well as perform active vulnerability assessments every 36 months. The way the NovaTech PAS system complies with Section 10 is that we start out with several tasks that the Orion LX performs. The first is that it retrieves configuration files from Cyper assets, including relays, settings, Orion files, and other types of information, and places those into a directory in non-volatile memory, as highlighted by item 1 in the overhead. Secondly, it normalizes file names to comply with the IEEE C37.232 and zips the files. 3, it transfers all zip files to the PAS integrity server using SFTP. This is noted in item 3, and you can see the network of servers at the top, including Active Directory server, Password Management server, PAS's integrity and SFTP server, and the Connections Manager server. Finally, it performs a ping to identify that all IP devices accessing the substation LAN. As a summary of the PAS integrity server tasks, it compares most recent transfer configurations to the baseline configuration file. It highlights any mismatches, coordinates these corrective actions and approvals, and creates the appropriate NERC reports. Now for some more detail about the specific function of the Orion LX in substation asset module. Turn the presentation over to Ray Wright.
Thank you, Kevin. Inside the substation, there's software running on an Orion LX, software specifically related to meeting the NERC CIP 10, but based upon software modules that already are used in the Orion for other applications. In this case, the access of settings information from the Schweitzer relays is done with a modification of our existing Schweitzer master protocol number 14. What we've done is we've added in additional ASCII commands to retrieve the settings. Also, we've added a scheduler feature in as well. That's designed to work with pretty much all of the relays that we currently connect to in substation automation applications. Now, some of our customers have said, what if I already have an RTU or an SEL communication processor in the substation? What if I have something that looks like what's in the diagram there, a legacy RTU talking to SCADA, maybe a 2030 or 2020 communications processor connecting through to relay engineering. In that case, it is possible for many, if not most, of the Schweitzer relays to establish a second connection. We do need to use the SEL protocol in order to access the settings files. Now, with that architecture, some of you may recognize this part of it as a potential NERC compliance problem. Having a dial-in connection or even a second broadband connection in from relay engineering would present other compliance concerns, so it may make more sense to do that passing through to the relays for engineering purposes through the Orion asset module in the substation. Compliance should be easier, and the protocol that we establish for accessing the settings information, that protocol can support also engineering operations to pull back full-length event reports and things like that, as well as a SCADA link. So that gets us to this slide. It is possible to replace the RTU and the communication processor with an Orion LX with the suitable software so that we can satisfy the information that's required by SCADA, by relay engineering, and also to the PAS integrity server. For GEUR relays, the modifications that we've done to the product is to issue some HTML web-based requests to retrieve the configuration settings, or we also can retrieve the settings using Modbus TCP, and we've added in a scheduling feature. As I mentioned before, we normalize file names to this IEEE C37.232 naming convention. This is what it looks like. An example file name there has the start date in year, month, and day, has the start time in hours, minutes, seconds, and I think that should be milliseconds instead of microseconds. And then there's a time code to indicate what time basis we have, station and device ID, and the company name. And for Schweitzer relays, we actually have to create a file. The settings don't come back in a file. We actually create a file, and we name that file. And what we do for the specific Schweitzer files, we also add in the port number. That's the port that the Orion numbered port to connect to the Schweitzer relay. GE relays, we rename the file because those settings can come in as files if they're accessed in certain ways. As mentioned before, we use SFTP to transfer the files. This is not just the relay files, also the files in the Orion. We use SFTP to do that using a function called file mover. This is a screen capture. Gives you an indication of the settings for file mover. You mentioned the task. You set up the schedule for when those files should be moved up. You make a selection for FTP or SFTP. You indicate the directory that is holding these files, these settings files. The Orion files will be in that directory as well. You move the contents of that directory to a location. That location may have a login. You have to put that in that field there with the password. Also, secure FTP, we have to indicate the location of the private key for encryption. And finally, you have an option to delete those files that are in that directory after successful transfer. This is a standard function that exists in the Orion. Ping is a function that we added in to meet some of the requirements for active vulnerability scanning. In the cases where Orion is serving as your entrance device in the substation, it would run through the IP address range on the substation LAN, and this will meet some of those active vulnerability scan requirements in NERC CIP 10. We have developed a smaller Orion. Perhaps some of you have heard about this. This is essentially a Orion that has the same performance as an Orion LX. It's a smaller one. It's called the Orion LXM. This is designed for smaller substations. It has fewer connections, but it does have the processing power sufficient to serve as an asset module in a NERC CIP 10 solution. It has actually a little bit more processing power than a standard LX, but a little less processing power than the most powerful high-performance CPU Orion LXs. And we think it's a good application here because this has universal mounting, and it can provide a more affordable solution if you are adding this into the substation where you already have an RTU solution, for example. Okay, Rich Powell is going to take the next portion of this where he describes the functions at the enterprise level through the PAS integrity product. Richard?
All right, thanks a lot, Ray. So to introduce integrity for those who aren't familiar with the product, as Kevin mentioned at the beginning of the presentation, PAS makes software for industrial control systems. One of the two major products is the integrity solution, and integrity performs inventory, configuration management, change management for control systems. Now, what's different about integrity is that we have what are called asset models, which give us the ability to translate proprietary configuration information from various to date, we support up to right around 80 different control systems. And one of those asset models is for the NovaTech Orion, which we're talking about today. So in the integrity application, we bring in information from the automation infrastructure. So these are the IT assets. So the operating systems on the servers, the HMIs, the routers and switches, Active Directory, bringing that into the database. Then the automation systems. So DCSs, PLCs, the IEDs in the substations. Also giving the ability to provision manual data. So you have the location information, any device parameters, megawatts, voltage, whether it's a critical asset, a BES cyber asset, or what have you. Whatever information you want to provision manually for the asset can be attached directly to that asset. So all of the configuration information from all of the different control systems and cyber assets under a single pane of glass into a database, and now you can run reports on that, have workflows against it, and report out both inventory, configuration, any compliance reports through a web interface. We do have full Active Directory compatibility, both for authentication and authorization, so access can be role-based. So one good example of how this has been applied in the SIP environment, we've worked with a large investor-owned utility for the past 2 years implementing integrity. They have it, this was in preparation for version 4, installed at 63 generating units. On the right-hand side on the picture, you can see the problem that they had. they had, across these 63 generating units, just a myriad of control system applications. And the old way of managing this was for people manually to go out and look at the systems with a paper and clipboard and document it in Excel. Using Integrity, they were able to bring all this information together under a single pane of glass and report on it at the corporate level. So the estimated savings just for the inventory portion by the utility was $3 million a year. So with CIP versions 1 through 4, most of the attention was given to routable protocols because you have the non-routable exclusion, which excluded most of the substations for people. But when you look at a control system, I'm going to lump substations into this. The routable portion, or the IT devices, so the workstations, the servers, the switches, are only a very small portion of the control system asset inventory. Now, moving from version 3 and 4 up to version 5, the non-routable exclusion is gone. So now all that in the configuration information and the inventory for these serial devices or these control systems has to be documented now. And that's where Integrity comes in. As I said, with the asset model, being able to bring all that information in, read it directly from either the control system or, in this case, the NovaTech Orion, being able to translate all that information up and present it to be managed within a single application. So giving a little bit more idea of the details, these are some screenshots from Integrity showing the information for one device. So each device contains each one of these tabs with all the different information. So what operating system or what firmware is loaded on the device, what accounts are provisioned on the device, what patches have been applied, what backups have been done. And you can see the direct application, CIP 10, R1, 2, and 3, CIP 2, R2, and R5, even into R9 with the backup. A little bit more. So now we're branching over maybe into servers a little bit, but the applications that are installed on the device, as well as ports and services, can be read in and documented. So now getting into the proprietary system side, and then we'll switch. I'm going to concentrate from here on out after this slide on the substations. But for a controller, being able to go all the way down to the card and channel level on those devices and documenting the configuration, even noting spare capacity. Now, as I said, going into the substations, pulling up the information, seeing what devices are connected to each port with the model and firmware available for each one of those devices, as well as the settings, which we'll see here in a minute. The second thing, now that we have all the configuration information for those devices, Integrity also has the ability to provision policies, configuration policies, or these baselines for the asset. So this can be used for, I'm going to take it a little bit beyond NERC CIP compliance, PRC5, the annual reviews, or what the relay configuration settings should be. So there's application on both the security as well as the operation side. So documenting how the devices should be configured and then also reporting up when the devices do not meet this configuration. And then finally, change management. Integrity comes packaged with a workflow engine. The basic workflow that's included is change control. This can be configured to the specific work requirements or workflow requirements of a customer. But most importantly, the embedded checklist and the approval routing and documentation. This allows proposed changes. So you have the testing requirements and documentation. These embedded checklists step people through the testing requirements and the evidence that's required as part of that testing, allows it to either be uploaded or linked to from within the change. Also documenting all the approvals, providing all your compliance information for the change control in one location, and then tying that to the configuration information allows these workflows to be intelligent. So we can trigger workflows based off conditions in the configuration table. One example of that is patch management. Providing a flat file input of available patches can be matched, using a workflow can be matched against conditions in the asset database, providing a list of devices that the patches apply to, and then tracking it all the way through testing and then implementation. So tying this all back together, looking at the overall architecture with integrity, the NovaTech communication server, also a partnership that we have with Tripwire to provide some more of the configuration data from Unix devices and network devices, really brings the capability to bring all your configuration information for the entire bulk electric system under a single pane of glass for management. So the control center, generation with the asset models for the DCSs, and as we're talking about here with Substation and the Orion LX, bringing up all those different IEDs, the configuration from those devices for management and reporting at an enterprise level. So with that, I'll turn it back over to Ray to close us up.
All right, let's see if we, the kind of questions we have here. When using SEL serial connections, how does retrieving settings impact SCADA data retrieval using SEL protocols? The same mechanism that's used to share that RS-232 link with record information is used with the retrieval of files. There's a ability to put both of those types of transactions on the wire at the same time. Some people call that interleaving, but there's the ability to still process your fast meter commands and your fast operate commands while you pull back the settings files or the setting information. Okay, let's see what else we have here. Okay, the first question. Can this solution be implemented without Ethernet connectivity? We often get asked that question. The Ethernet connectivity between the substation and the enterprise makes it possible for the automatic sending of the files via SFTP. I think the answer to that would be that Ethernet or broadband connectivity will be required between the substation and the enterprise for the NERC CIP 10.
But Ray, I will add there that we have also worked with a couple data diode manufacturers and fully support that so that you could retain the non-routable process.
Okay. Feel free to describe that a little bit more, Richard.
Okay. So implementing the data diode allows you to still maintain that non-routable exclusion. So whether it's a software data diode or the hardware-based data diode, you very, very defined data flows from the substation to, I'm hearing the echo here, up to the head end. So, and I understand the question, the advantages of maintaining that serial connection or not having external routable communication means your exposure to the CIP requirements is less, specifically in CIP 4 requirements and a couple others.
Unmuted.
All right, Ray?
Thank you, Richard. Let's see if we have some more questions here. What will be the upgrade path aside from providing protected LAN connectivity to a station to implement the PAS NovaTech solution? What kind of upgrades are required to existing production Orion LXs? Would they need to be replaced? The Orion LXs that would be running the software that was described in this presentation, those Orion LXs could be upgraded Orion LXs, or they could be new ones. So this does not require any hardware upgrade on the Orion, nor does it require anything other than firmware changes to the product. So it would require a firmware upgrade and the addition of modified protocols, different SEL master protocol, and some other modifications to protocols. But again, all things that can be done without changing physical aspects of the Orion. Let's make sure we answered that right here. Let's see. Upgrade path aside from fronting protected LAN. What we'll do is there's a more complete answer to that question. What I'd like to do is to get back to the attendees with a more complete answer after we've spoken to a couple folks internally about that. But we will hold on to that question. We know who asked it, and we'll also provide an answer to other attendees. Let's see what else we have here. Okay, I think that's all of the questions here. Let me double check. There's okay, hold on a second. We're paging through this. Good question. There's another question come in. Will this work with SEL TCP? I'm glad you asked that because we just went through that just before the webinar. The answer is yes. The modified Schweitzer protocol number 14 will be able to be transferred over TCP. We call that STCP, and sent to a terminal server. A terminal server could be an Orion with SPAS and MPAS running in it, stripped down to only do the terminal serving function. And yes, that will work in the architecture that we described if you need more serial ports. Okay. Does the latest firmware version of the Orion LX have the feature to retrieve config files from the relays and sending to PAS? If not, when will it become available? Existing firmware does not have that feature in. What I'd like to do is to have a conversation with engineering on this and get back to the person that asked this question. Okay. Let's see if we have anything else here.
Ray, I can take the question about the cost of PAS software and how it's licensed.
Okay.
We license the PAS integrity software primarily by the base software and then the different asset models which are required to communicate out to the individual substations or the various control systems. So, and really the cost varies. We offer volume discounts, so it really depends on the individual situation of the customer. But the base integrity software is not very expensive at all. And then depending on the asset modules, as you have different communication control systems in to communicate and be managed. I'd be happy to get with the asker of the question and talk about their specific situation.
Unmuted.
And I think just to add to that too, Rich, is that every application will be a little unique in how it's applied and implemented based on what's required in the substation, what's required at the enterprise level, and how the final system is configured. So, you know, we'd really look at specific application and the implementation plan and develop a proposal or a price for that specific application.
Mm-hmm.
Okay, we have a few more questions here. The next question says, login for file retrieval seems to require a manual entry for the password, which does not seem to be integrated with a user management system. From the Orion standpoint, since the Orion does retrieve the settings information automatically, again, this will be a scheduled task, and yes, the Orion does need a password to do that. The passwords that Orion will have in it to access settings information from the relay will be integrated with a password management system that's being developed by NovaTech at the enterprise level. This is an enhancement. This takes some of the password architecture that's currently in NCD and modifies that. So Orion would have the password. Orion would have a pre-configured schedule as to when to go down and get the settings information from the relay. Orion also would have a schedule for when the files were to be SFTP'd up to the PAS integrity server. Also, there's a file naming option in there as well. The files can be renamed to normalize them to the IEEE 232 naming convention. A lot of questions here. Would there be an option in the future for IPsec tunnels? Yes, there are options to set up secure pipes for data between the Orion and upstream equipment. I'd like to, again, talk to engineering about this and come back with a more considered response. Okay. It says you have only shown an integrated solution with SEL and GE relays. Can you speculate on integration with relays from other vendors, such as ABB and Basler? Good question. The first two that we did were part of some projects we're working on right now. We also see a lot of the SEL and the GE relays, but there are other relays out there. Turns out that the SEL and GE relays do provide, let's say, some more straightforward mechanisms for automatic settings retrieval. I do know that some of the ABB relays have straightforward mechanisms to do that. Other ones require use of PC-based software. We are looking at these other products, and again, I'd like to work with the person that asked this question specifically to see which model we're talking about, and then we can figure out when would be the way to work that in. I'm pretty sure that some of the ABB transmission relays, like the RAL 512 that supports the ASCII interface, I'm pretty sure we should be able to get the settings files, or the settings information back from that relay in a mechanism similar to the way we do it with the Schweitzers. Good questions. Okay. I'm also interested in the SNMP traps feature going through a data diode to our control center. Do you want to talk a little bit, Rich, about the data diode approach that we're looking at with that other supplier, or do you want to pretty much make that another topic discussion later on?
Really, that's another topic, but with the data diode, being able to push traps out or collect them up as they're being pushed from the end devices is really not an issue.
Unmuted.
Okay. Let's see here. Can the LX in the sub change the passwords in the IEDs without enterprise software? We are looking at a number of different ways to do this. The first architecture we looked at, the password changing would be a function of an upstream password management system. It is possible to certainly write some custom script in the Orions to do that kind of thing. What we'd like to do is to talk to the person that asked this question, find out a little bit more about the reason behind why this might be desirable, and we will share the response with the attendees. How could one include configuration files from relays other than SCL and GEUR? Touched upon that earlier in the question and answer session. I think a lot of it depends on whether the relay supports automatic access, or let's just say straightforward automatic access of the settings information or the settings files. We do know that a lot of older legacy relays do require access of settings using a PC-based configuration utility. Obviously, booting up a PC-based program and going through some script to emulate the keystrokes, doable, but it can be difficult to reliably automate. But again, we'll look at that on an individual case-by-case basis. Our plans are to continue to expand that library of devices that we can access and retrieve settings information from. Do you charge per SEL relay or LX? I think the answer to that is we don't have that. We don't have a model for that yet. Anything you'd like to add on that, Kevin?
Yeah, we're working up a pricing model that would be scalable and flexible for utilities to put in. So depending on the number of critical cyber assets, as well as the overall scope of the utility, that they would be able to start in with a system and scale it up as additional needs arose. And so with that, we're thinking more that it's going to be based on a substation basis as opposed to an individual device because we recognize that many substations contain lots of devices, different type of IEDs. Some of them don't, but the actual connection is through the Orion. So we think by having it based on the Orion asset module makes the most sense, and that's what we're working on right now to finalize.
And from the integrity side, we do charge by LX, and as I mentioned before, there are volume discounts as the number of devices increases.
Next question, will this manage any switch and router configurations? I'm going to turn that one over to you, Rich, as to the mechanisms you use to manage switch and router configs.
As I mentioned in the beginning, we specialize in control system configuration. Now, we do have a couple partnerships with, as I mentioned, Tripwire, and we also have another partnership with SolarWinds to bring in network device configuration. So yes, we manage switch and router configuration in the integrity that's real.
Okay, I think that might be the last question. If we missed a question, we will see them and we'll get back to folks. I think we got them all there. Again, we'll double check and we will summarize a response for all these questions and get back to the attendees. Adding to the responses, we'll listen to the recorded response and add to that, and again, we'll send that out. Kevin?
So we'd like to thank everybody for participating today in this webinar. We plan to have a few additional webinars in the NERC CIP compliance series, and those dates will be posted on our website, as well as we'll email notifications out to our contact database. Also, we'd encourage you to go up to the website and visit it. Look at the previous webinars that are up there recorded. This information will be up shortly on the website as well. And we'd also encourage you to contact your respective sales regional folks for any additional information that you'd require that can be funneled back through the organization. Again, on behalf of Richard Powell, Ray Wright, and myself, and the entire NovaTech team, we'd like to thank you and have a great day.